Hello everyone and welcome to this video on creating computer-aided manufacturing programs in Autodesk Fusion 360. If you would like to follow along with this example, you can find the F3D file in the video description below. Okay, in this particular example, we're not going to machine all of the geometry that you can see on screen now. Hopefully you can see that the geometry of this component is very similar to the CAM example 2 video that I've already released. So you can see how to create most of these features on that particular video. The one difference here is that we have a number of pockets with large rounded corners in the bottom of the pocket. So basically this video is about what to do to create these features and a bit of a warning really about why we shouldn't be designing pockets with large rounded corners in the bottom if we're going to be milling these on a 3 or a 5 axis mill. Okay, so by default Fusion 360 has put us into the design workspace, so we want to go to the manufacture workspace. And the first thing that we do for all computer-aided manufacturing programs is we create a setup. So I'm going to go to the new setup button. We are creating a milling operation. I'm going to double check the orientation and location of my work coordinate system. I can see that my z-axis is in the correct orientation and that the work coordinate system is located in on the top face in the center, which is correct. I need to tell Fusion what I'm actually machining, so I go to my model selector and I select this model that I'm actually machining, and then I'm going to enable the fixture option, and I'm going to pick the two vice jaws at the bottom to set those as the fixture. I move across to the stock tab, and if I change to the right hand view, I know that I need to set the size of the stock so that it locates properly within the vice jaws. So if I increase the side to 2 millimeters and then increase the bottom to probably 4 or 5 millimeters, 5 millimeters, there we go, I can see that that locates the stock properly within those jaws, and I can press OK. Following the creation of the creation of my setup, the next thing I'm going to do is create a probing operation. This will properly locate that work coordinate system in the center of that top face. So I go to setup and probe. For my tool, I'm going to go to the sample probes area and I'm going to pick a 5 millimeter probe. I'm going to specify a sensible lead-in velocity of 5 millimeters a minute, and then move across to the geometry tab. Now I don't want to probe the model, I want to probe the stock, and I want to set that work coordinate system. So I've set that to stock, and I want to click this top face as the piece of the stock that I want to probe. And we can see that automatically Fusion has created a probing toolpath which will touch on the top of the stock and each of the sides. I'm happy with that, so I can press OK. The next thing that I want to do is I want to create a 2D face milling operation. So if I go to the 2D tab and I go to face mill, under my tool selector I can select, or I'm going to use the tools from the sample metric library. So expand the samples area, I go to tutorial metric, and then I want to pick the only face mill to which I have access, which is the 50 millimeter face mill, and press OK. I'm happy with the default feeds and speeds which have been brought in from the library, so I can move across to the geometry tab, and I'm happy with the default geometry for the face milling operation, so I can move across to the heights tab. I can see that the default heights have been set to the top height is the top of the stock, so this is where I'm going to start machining, and the bottom height is the top of the model, so that's where I'm going to stop machining. I'm happy with that, so I can press OK, and that will create my face milling toolpath. Okay, so let's just simulate that quickly, and we can see what stage we're at. I have my, I'm going to enable my toolpath visualization, I'm going to enable stock visualization, and I'm going to set my colorization mode to comparison, and then just play that. And I can see the probing operation followed by 2 passes of a face mill. I can see that the top of my model is green, so I've face milled to the correct height there. So what I need to do next is I need to fully machine each of these pockets. Now for the purposes of this video, I'm going to look at one of the pockets with a square edge and one of the pockets with a rounded edge and just show you the difference. So let's start with the square edged pocket first. For this I'm going to use a 2D adaptive clearing operation, so I go to 2D and 2D adaptive. First I need to select my tool, so I go to select, Now I know that the radii in the corners of these pockets are 5mm, so normally I would select a 10mm cutter. That being said, for this particular bit of geometry, we can see that the area of the pocket is quite small. Now, if I put a 10mm diameter cutter, or I use a 10mm diameter cutter for this particular operation, it doesn't leave the software a great deal of room, of breathing space to create that 2D adaptive clearing operation. And in some cases you might find that it can't actually create a toolpath because it's not got enough room to operate in. So what we're going to do here is we're going to select a smaller cutter. I'm going to look at something like an 8mm bullnose cutter, and we'll see if that works. Selected the tool, so I go across to geometry, and we're going to look at this back pocket here. So I'm going to pick a contour which selects that pocket for me, and then I'm going to go across to heights. So I want to start machining at the top of the model, and I want to stop machining at the bottom of that pocket. So I'm going to choose selection here and pick the bottom of that pocket. I'm going to press OK and see what that generates for me. Now we can see, even though we reduce the size of the tool, we're not really letting the tool move very much in the XY plane. So if we simulate just that tool path, you can see the tool spirals in and then moves out in very small increments. So if you are having issues with getting 2D adaptive clearing operations to work properly, it might actually be that the tool is too big to allow proper generation of that tool path. So I'm happy with that. I can see that I've left the default option on the 2D adaptive tool path. Under the passes tab, this will default to leaving stock of 0.5mm radially and axially. I'm fine with that because this is a roughing tool path. So the next thing I'm going to do is I'm going to do a finishing operation to finish off the inside of this pocket here, and for that I'm going to use a 2D contour. So I'm going to use a 2D contour for the tool. This time, because I do have the room, or I will select a 10mm flat end mill. For the geometry, I'll select the inside of the pocket. For the heights, I want to start machining at the top of the model, and I want to stop machining at the bottom of the pocket again. And we'll just see what that creates. So again, let's simulate this. We're just going to skip through the probe and the facing operations, and let's see what this does. So we've got the 2D adaptive clearing, and then we've got a single contour operation. And if we slow this down and we repeat that simulation here, we can see that actually we've got stock on the side and on the bottom of the pocket, but because we're using a tool which is quite a large diameter for this contour, actually, as slow this right down, as this tool comes in for the contour operation, it is big enough so that we don't actually need to worry about clearing up the bottom of that pocket. So that pocket is completely finished, and we're happy with that. So we can close this. Now let's compare that to, for example, this pocket here. We have a very large radius in the corner here, so we need a completely different strategy. Now within Fusion, probably the best way to do this is to use a 3D adaptive clearing operation. So let's look at what we need to do in order to do that now. So if we go to 3D adaptive clearing, I'm going to select a tool. I'm going to go to metric, and again I'm going to pick my 8mm bullnose there. If I go across to the geometry tabs, we need to change this from the default settings quite radically. So by default this will be set to stock contours. We don't want this. We actually want to set a machining boundary, and we want to select what machining boundary we have. And for this purpose of this, we're going to use this contour here, which represents our pocket, and the default will be to contain the tool outside of the boundary. We don't want that. We want the tool inside of the boundary. If we move across to heights, we want to start machining at the top of the model, and we want to stop machining again at selection, which is the bottom of the pocket. If we go across to passes, we will leave the default stock to leave option of 0.5 millimeters radially and axially. And if we press OK there, we can see that we generate a rather complex looking toolpath. And if we simulate that toolpath, we can see what Fusion is actually doing. So again, it will spiral into the component in a similar way that we get for 2D adaptive clearing, but then it's going to change its toolpath on each increment of the Z height. And it's going to step down, and it's going to try and follow that radius in the corner the best that it can with the tool that it has. Okay, and we can see that we get this stepped geometry here. And again, we've still got stock left on there. Now, what we need to do now is we need to clean up the inside of that pocket. So if we close this, and if we do a similar contour operation to what we did over here, so we go to 2D contour, we're going to select the tool. Again, we're going to go to tutorial metric, but this time we are going to pick a 10mm ball nose cutter, because the radius of that ball is going to properly follow both the inside of this pocket and this radius that we have on the bottom of the pocket here. So I'm going to press OK. For geometry, I'm going to pick this contour here. And for heights, I want to start machining at the top of the model, and I want to stop machining at the bottom of that pocket. So I can press OK. So let's just let's simulate the whole setup, and let's skip through a few operations. So we're here where we have adaptively cleared using a 3D adaptive clearing operation all of this material. Now let's have a look at what the 2D contour operation does. So we've got our ball nose cutter, we move in and we clean up the inside surface of that pocket. Now while the bottom radius here and the internal pocket radii look good, we can actually see that we've got some excess material remaining on the bottom. So we need to clear that up. So we're going to close this, and we're going to go to 2D and 2D pocket operation. This time we are going to use, what have we already got? We're going to stick with our 8mm diameter bull nose. For the geometry, I'm just going to pick this flat, the inside or the perimeter of this flat surface on the bottom. And for heights, I want the bottom height to be the bottom of the pocket, and I'm going to select the top height to be the bottom of the pocket also, but then use the offset to move that up by a few millimeters and press OK. So let's simulate the whole setup, and we'll skip through a few operations. So we've got to the stage where we've done our 3D adaptive clearing. We're then going to go in with our 2D contour operation and our ball nose cutter. And then next we're going to have our 2D pocket operation. We can see that's going to come in, and that's just going to move around that bottom surface there. Now I think I've actually made a mistake with this toolpath. I think I've left the default option enabled, which will leave stock on this 2D pocket operation. So we're going to close this. I'm going to edit the 2D pocket operation. On the passes tab, I'm going to remove this option that says stock to leave. And we're just going to simulate all of that again. So we're here. So let's see what this 2D pocket operation does now. It's going to spiral in, and it's going to remove material on the bottom. Now, this isn't great because we can see we've left excess material in this corner here. So if we imagine this line here is being cut by the ball nose cutter on the 2D contour operation, and this line here is being cut by the ball nose cutter on the 2D pocket operation that we've just seen. Now, we can keep reducing the diameter of this tool to get closer and closer into this corner, but we will never reach a point where we can remove all of this material. There will always be some material here, even if we go to very small cutter diameters. So in order to pick the best approach for milling pockets of this kind, we need to properly understand what their purpose is. Is it important that, you know, we remove this material? Is there a component that seats in here? Is this going to cause an issue? And we need to adapt our milling strategy accordingly. Alternatively, we could pick a little bit more of a messier approach. So we could use a single 3D adaptive clearing operation for the entire pocket. So if we go to 3D adaptive clearing, this time I'm going to pick a 10mm ball nose cutter. For the geometry, I'm going to pick the inside of that pocket. And actually I've picked that wrong, so be careful of this. We do not want stock contours. We want a machining boundary. We want a selection. We want this pocket to be the machining boundary, and we want the tool to be inside the machining boundary. For the heights, we want the top of the model for the top height, and we want the bottom of that pocket for the bottom height. And on passes, this time I'm just going to remove this option that says stock to leave, so it should just machine all of that pocket in a single tool path. We can press OK, and we can see that that's actually done that now. So let's simulate that particular tool path. So again, it's going to spiral the tool in and then move out gradually. To try and create all of that geometry. Now we can see that in the corners here, the tool path is not quite lined up with the contour of that radius, meaning that it's left excessive amounts of material there. Potentially we could get around this by using a smaller diameter tool, but more worryingly, on the bottom face of this pocket we have a lot of artifacting or cusps. Now because we're using a ball nose cutter for the entire operation, there is no way that we can get a perfectly flat surface here. We can reduce the step over amount, so we can reduce the distance between these two passes which are next to each other, and we can keep doing that, but we will never get to a stage where this is completely flat. So hopefully this has highlighted a bit of an issue with creating geometries of this kind. If we just skip right to the end, we can see that no matter what we do, we're either going to end up in this situation where we have some artifacting in the corner here, or we're going to end up in this situation where we have potentially a very excessively long cycle time, and we have artifacting across the bottom of the pocket. So really, if we can avoid situations where we have large rads in the bottom of pockets, it makes the machining or the milling of components certainly much easier. Okay, if you'd like to see how to mill the rest of the geometry on this model, most of that is covered in CAM Example 3, so I would suggest that you have a look at that video also. Okay, thank you very much for your time, and I will see you in the next video.